Namaste. Welcome to this channel, Dr.ARM's Chemistry. We were discussing last time the coordination chemistry, and we have seen the introductory part of that coordination chemistry. It will be further discussed in the transition methods with reference to various factors. Today, we are going to see this new topic, that is chemistry of 3D elements. And the first point of this topic is the general characteristics and properties of transition methods. If you see what are transition methods, then we find that these are located in periodic table in a specific place, which is mentioned here as like this. So if we see the periodic table, then we find that there is, see, as there are other blocks also. See, this is S block. Then there are so if we divide this, we can find that there are 7, 2, 3, 4, 5, 6 and 7 horizontal rows. So this gives the S block. So here we can show N, that is principal quantum number or main shell number. So this is 1, 2, 3, 4, 5, 6, 7. So here we can show the elements with their increasing atomic shells or with addition of new shells. Then here we know that there is elements like this. That is hydrogen, lithium, sodium, potassium, rubidium, cesium and calcium. And we can show the other elements here also. Then if we want to name number the groups, we are naming it as 1. So this is 2, second. Then from the fourth period, we are showing here the 10 columns like this. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Like this. And 2, 3 and 4. So these are the group numbers starting 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this block is called P block. So this is called P block elements, which are ranging from 3 to 12. Then the next is like this. So this is a block containing 6 groups, 3, 4, 5 and 6 levels. Then These are the periods like this. Then we can number the groups like this: 13, 14, 15, 16, 17 and 18. So this block is called P block. P block elements. So these are the group numbers. So we have shown the group numbers. So these are shown in this way. So this is group number like this. So everywhere we have shown these group numbers. Now the group 1 elements are called alkali metals. Then group 2 elements are called alkaline earth metals. And these P block elements are called the transition metals. These are called transition metals. And these elements are called regular elements or normal elements, which contain metals as well as non-metals. And the last group is called inert gas or elements. Then these are called also halogens. So this type of naming is also previously shown in the previous chapters. So we need not go into that detail. Now we have to concentrate on these transition metals. So you will find that this is not P block, this is D block elements. So this is S block, this is D block, this is P block. And in addition to this, there is one more block called F block. So it contains 14 groups: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. And there are 2 series of these elements. So these are called F block elements. These are called F block elements. Out of which these are called, you can see, 4F elements, 4F, or we can say lanthanides. And these are called 5F elements or actinides. So if we take this third group of the periodic table, then we find that there are elements starting from this 6. So here we can show these symbols like this. This is second series, starts with here. That is actinides. So the elements coming after lanthanum are placed in the 6th period, and actinium is here, and it is the beginner of that 5 elements or actinides. So these 14 elements are having position in this group of 6th period. All these 14 elements of high-up or actinides have the position in this box, we can see or place. It is a member of 7th period and 3rd group. So 14 elements are coming after this actinide. 14 elements are coming after this lanthanum. So lanthanum and actinium are the members of these 3rd group. And the 5F series or 4F means lanthanide series of 14 elements begins or coming after this lanthanum and ends here with this element of 71, and here next element is hafnium. So in this way, in short, this box shown in green color is the position in periodic table shown with or named as transition elements or transition metals. So we can find here this important location in periodic table. Now we know that the elements which are shown here are called alkali metals, and elements shown here, if we are not shown everywhere, but the elements which are positioned here are alkaline earth metals, and these are transition metals. Now if we see the nature of compound studies, these elements give mostly ionic compounds, and these elements of S block gives preferably the ionic compounds, and the elements of this transition block or transition type, that is D block, gives covalent compounds. These are also giving some ionic and covalent nature, but these elements, P block elements, are giving covalent compounds. Now if we see the elements, electrons here, we find that the S block, if we go on filling the electrons here, so first electron goes here in the first period in the first group. So hydrogen has one atomic number, it contains one electron. Then there is next so the first period has here He, helium with 2 electrons, and in this way the number of electrons are shown here, so we can show that 2 He. Then the next is third, lithium. So in this way 3, 4, 5, 6, 7, 8, 9, 10. So here helium, neon, argon, krypton, xenon, etc. Helium, neon, argon, krypton, xenon, etc. So these elements are coming called inert gases. Now we can have these elements here with 2 electrons. So 2 electrons are filled in S block. First electron, second electron. First electron, second electron in this. Then transition element shows filling up electrons from 3rd group to 12th group. So the electrons contributed by these elements or 11 electrons. So first electron is coming here, second here. Then next electron means comes here in the D block. So the total number of electrons contributed in the D levels, these or bindings, are starting from 3rd group to 12th group. So total number of electrons contributed are 10 by D subshell. Then S subshell contributes 2 electrons, and F subshell, first of all we will show the P subshell, 6 electrons. So total it gives in this way in the period how many electrons? 18. 10 plus 6 plus 2 means 18 electrons. But excluding this D block, if we count the electrons contributed by these series, are only 8 electrons. So before that the contribution is only 2 electrons, but the contribution of these is 10 electrons, and contribution by these 14 will be appearing from lanthanum to here in these 2 series. is of 14 plus this 18 means 32 electrons. So in this way, the number of electrons means you will find that the first two elements shows that the electrons are duplicate, means two electrons can be contributed in this series 1 and 2. So it completes the duplicate with this helium. Then lithium to neon completes the octet, means 8 electrons. These elements containing 8 electrons means third electron we can say 1, 2. But in this series, that is the first electron goes here, second here, third, fourth, fifth, sixth, seventh, eighth. So a group of these 8 elements is called octet. So octet is completed. Here is also octet is completed. Next, there are 2 rows giving the group containing 2 plus 10 plus these 6 means 18 electrons. So we can totally show here 18 electrons. 18 electrons. And after these 2 groups, there is a group of elements in which the electrons are progressively filled and they show 32 electrons. So you will find that the electron cloud is expanded from 2 to 8, 8 to 18, 18 to 32. Then we will show that, we will find that if we consider only means we are concerned only with the D block elements, that is starting from group 3 to group 12. We find that the electrons are progressively filled. Say this is called, you will find that this is called D1 electron. So first electron goes into the D orbital, that is called a 3D. So we can show here 3D begins with 1 electron. So this is 3D. So 3D begins here with, so 3D begins in this direction, 3D, then 4D, then 5D, then 6D. So these are the series of transition elements. So first electron goes into this D1, then this is D2, in this way D3, then D4, then D5, D6, D7, D8, D9 and D10. So in this way D orbitals are progressively filled. So when we move along this period, and we find scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, etc. So every element shows progressive filling of new electron. So the D orbital contains in this way D1, D2, D3, D4, D10 electrons, and therefore they are called transition elements. Means where the transition comes in relation with the properties exhibited by these elements. You will find that these elements, alkali elements, are most strongly electropositive. The electropositivity of this second group, that is second group, is relatively less, and these elements are having properties which are in between of these p block elements. So properties of these s block elements are progressively changing towards the p block elements through this group of transition elements. So these d block are showing transition of properties from s block to p block, and that is why they are called transition elements. They elements showing specific characteristics, but the elements of this D10 here show that the D level of that element is complete, or the D subshell is full. So these elements which are present in these groups are excluded as non-transition elements. They are not considered as transition elements. So this is mostly because most of these elements shows exclusively different characteristics. Say that is colored of compounds, ionic characters, etc. They show magnetic properties. But these elements do not show such colored characteristics. These elements do not behave like these remaining D block elements. So they are these elements shown here under this D10 or 12 group are excluded, means they are not considered as transition elements. Then if we see the example, the group of metals called copper, copper, silver and gold. Copper, silver and gold is called a coinage metal. Coinage metals. So they are having greater stability and they are also having costly, means they are having pleasant appearance, means ornamental characteristics, and that is why they are called coinage metals. And most of the elements are or have had used in the developing the coins or currency, and therefore they are called coinage metals. The copper is, when the copper is in 2+ state, it is 3D9. When copper is in 2+ state, copper 2+ is 3D9. Then if we see Ag plus, that is Ag plus iron, it is called 4D9. And similarly gold Au plus is having 5D8 configuration. And because of this they are called also transition metals. So these elements are no doubt very highly stable, but they exhibit greater stability under the atmospheric conditions or under reaction conditions. Zinc, cadmium and mercury. Zinc, cadmium and mercury, which are of these groups, zinc, cadmium and mercury, are the members of transition group which are ending the series, means they are called end members of the 3D, 4D, 5D, and therefore they are also called transition elements. Now another important feature of this transition matrix shows that if we count the total number of such transition elements, it contributes the largest volume of the periodic table. So out of 118 elements, means actually there are 117 elements in periodic table, and starting from atomic number 1 to 118, but out of that 117th element is not yet discovered or obtained. Then if we count the total number of such elements, we find that out of 117 elements, means 1 to 118 excluding 117th element, so total number of elements shown in this periodic table is available at this time are 117, and out of that 117 the transition elements are 68. The count of transition elements is 68. So this includes, you will find that the first series contains 10 elements, second 10 elements, third 10 elements, fourth 10 elements, so it becomes 40 elements here, plus these 14 plus 14, 28, so it gives total 68 elements which are called transition elements, and it contributes, or it is composed of the periodic table shows major contribution of these transition elements in the periodic table. Then if we see there are some characteristics, they show that, means all these elements, the 4 series, so they resemble in their characteristics with each other, and some of them are behaving very likely or closely. If we see the physical and chemical properties, they shows that all these elements are metals, and therefore they are called transition metals, and some of them are highly important with respect to industrial applications. For example, if we see the iron, titanium, chromium, nickel, copper, molybdenum, tungsten, zirconium, vanadium, as well as uranium, thorium, etc. So there are various important elements which are having industrial applications. They are, all these transition elements are, they are very hard. They are having high melting points and boiling points. Then they are also having strong metallic strength. They are good conductors of heat and electricity also. If we see another properties, that is ability to form alloys, it shows that all these elements can form alloys with various other metals, and because of their alloying formation or alloying ability, capability, they can show the applications in variety of fields, that is maybe industrial fields or any other fields. They are showing greater applications. In addition to this, they are more electropositive but less electropositive than the alkali metals and alkaline earth metals. They are electropositive and they are soluble in acidic solutions, that is mineral acids. They show various or varying oxidation states. With the oxidation states exhibited by, they can exhibit oxidation state like say this +3, then it can have +3, +4. So in this way, they are showing +3, +4, +5 like that oxidation states. If their oxidation state is varying, some of them are also exhibiting +1, +2 oxidation states depending upon their electronic configurations. So that is another part of our discussion. We are discussing here the physical properties in short. If we see the color exhibited by their compounds of ionic nature or any other nature, these almost all compounds show colored compounds or complexes. But the compounds which are present here in the last group are giving mostly colorless compounds. Then they show paramagnetism. All these elements called transition elements show paramagnetic properties. Why? Because the electrons are distributed here in the D subshell. That is first electron, second, third, fourth. So they are having containing the electrons in the D level either 1, 2, 3, 4, 5, 6, 7, 8, 9 or 10. So depending upon their electronic nature, they may exhibit varying number of unpaired electrons, and because of this they can exhibit paramagnetism. And when the electron is not a single electron or the element does not contain unpaired electron, it shows dimagnetism. So these metals are also included as transition metals, and therefore they also exhibit the paramagnetic behavior and diamagnetic behavior depending upon their electronic configurations. All these metals form good number of complexes with various ligands, because these metals are good Lewis acids and they can strongly or easily form good number of complexes with monodentate ligands or polydentate ligands, and depending upon their coordination number. So coordination number depends upon oxidation state of the metal, and depending upon that coordination number, these elements give various complexes with different geometries like linear molecule, which can be exhibited by silver as AgNH3 twice Cl. So in this way, starting from the coordination number 2, the elements can give variety of complexes like planar, trigonal, then square, planar, tetrahedral, octahedral, then pentagonal, bipyramidal, etc. So there are variety of such complexes exhibited here. So this is about the short look on these various properties exhibited by these transition elements. Then later on in the next lecture we will discuss remaining properties. So we will stop our discussion here and we will continue the next point in the next lecture. Till then, goodbye, see you next time. Please subscribe to this channel, press the like button and bell icon, and you can put also your comments. Thank you very much for watching this video.